Hello friends and students, it's MoNaCo here, our second video in our first unit on safety, matter, and measurement. This video is devoted to page 9 in your unit packet. We're going to talk about different types of error and the equation for calculating percent error. So the first things first is we're going to talk about what a human error is. Human errors are error associated with the person doing the measurement. If you make a mistake or you hold the tool wrong or not do it correctly, do the measurement, there's going to be some error associated with you and who took the measurement. Instrument errors they're built in. They have a plus or minus from the value that is always read off the instrument. So the instrument itself has error, but sometimes the instruments are broken, not functioning properly, and that contributes to the percentage error that can be calculated. A measured value is a number that you get when you measure. So if you measure the desktop to be a certain length, that would be your measured value. In percent error calculations, we compare the measured value to the accepted value, which is the number that one should get if measured correctly. So for example, the blueprints for the desk say you should have gotten 95 centimeters, but you measured 90. There's a difference, and you apply those numbers into this formula for percent error, which means that you take your measured value away from your accepted value. And you take the accepted value, find the difference between the measured and the accepted value, and you divide it by the accepted value and multiply by 100 to get it into percent. This way you can see what percentage, how close you are in a percentage to what you were supposed to get. If you're more than 5% away from what you were supposed to get, you should really think about going back and doing your measurement again. Lower than 5% or lower than 1% is really amazing, excellent error. So if your calculation for percent error ends up as a negative number, it means that the measured value that you got when you measured the device is lower than what you were supposed to get. So there'll be a negative sign out in front of your percent. If your calculation for percent error ends up being positive, that means the value that you measured is actually a little bit bigger than what you were supposed to get. But generally speaking, if you keep your error small, low, below 5%, you're doing just fine. So if you're still having trouble calculating percent error, there are a ton of resources out there to find and use. First of all, our textbook, chapter 1, has some percent error in it. Second of all, the keyword searches calculating percent error are going to get you a ton of websites with a lot of practice problems to do. YouTube, keyword, percent error. The key here is not to practice until you get it right, but to practice until you can't get these calculations wrong. You will always have the formula in your reference, but if you memorize it, you'll always have the formula in your mind. Thanks for watching. Have a good day.